Bismillah wa salatu wa salam ala Rasulillah. Welcome to General Chemistry with Dr. Zainab. Today we are going to solve recitation problems for chapter 2, which is about atoms, molecules, and ions. So please get your periodic table of the elements ready and also the table with the common cation and anion. So problem number 1, calculate the densities of a hydrogen nucleus and a hydrogen atom. And we have the mass of the proton, of the neutron, and also the electron that are given, but also the radius for the nucleus and the radius for the hydrogen atom. So let's remind the formula to calculate the density, G equal to M divided by the volume. So if I want the density of the nucleus, I need to have the mass of the nucleus, which is given, and the volume of the nucleus. So here you have to consider the nucleus as a sphere. So the volume will be equal to 4/3 by R nucleus cube. Okay. So the density of the nucleus will be equal to the mass 1.67. 10 to the power minus 27 is in kilograms, so we can convert it to gram. This is in gram, divided by 4/3 pi, and the radius, which is 5, 10 to the power minus 14 cube centimeter cube. So it will be given in gram per centimeters cube, which is equal to 3, 10 to the power 15 gram per centimeter cube. Okay, and similarly, we can get the density of the atom, which will be equal to the mass of the atom divided by the volume of the atom, and we'll use the similar formula. So 1.67, 10 to the power minus 27. You need it in gram, so we convert the kilogram, and the volume will be 4/3 pi, and the radius is 1, 10 to the power minus 8 power 3 centimeter cube, and this will be equal to so if you compute it, it's going to be equal to 0.4 gram per centimeter cube. So the key point here is just to remember the formula for the density, and also to consider the atom as a sphere, and then this will be the volume, 4/3 pi R to the power 3. Okay, so for exercise number 2, here you need the periodic table of elements. So here we have the symbol with the Z here. So you have the Z and the number of the mass number. So if I have any element X, here I will have Z, which will be the number of proton, and A, which will be equal to Z plus the number of neutron. Okay, so we will use these two formula to complete the table. We also need to know what is the charge of any element. So if the number of proton and the number of electrons are equal, the atom is neutral. If it's charged, it means that the number of proton Z minus the number of electron is not equal to 0. So either you have more proton, either you have more electron. Okay, so we use this to compute for when we have a charge, like when we have 2 plus, we know that the number of protons minus the number of electrons will be equal to +2. So here the number of proton is directly equal to 26, which is the Z, okay, atomic number. The number of neutron, we know that the mass number equal the number of proton plus the number of neutron. So N will be equal to 53 minus 26, meaning 27. And here the net charge is 2 plus, meaning that Z minus the number of electron is equal to 2 plus. So the number of electron will be 26 minus 2, 24. Here they give us the number of protons Z. So we know that it's going to be iron. If we look on the periodic table, so we have 26. And the number of proton plus the number of neutron, 26 plus 33 will be equal to 59. The charge, net charge is 3 plus. That means that I have 3 more proton than electrons. So 26 plus 26, 26 minus the number of electrons will be equal to 3. Okay, so it's going to be 23. Okay, here they give us again the Z, the number of protons. So if I look on the periodic table, aluminum is the element with Z equal to 13. So we have 13 here. And the number of mass will be 13 plus 14, so 27. And we have the number of electrons that is equal to 10. So 13 minus 10 will be equal to 3 plus. So we know that it's aluminum 3 plus. Here we don't have the Z, so we don't know what is the element yet, but what we know is the number of electrons and the charge minus 2. Okay, so we know that the number of proton Z minus the number of electron will be equal to minus 2, meaning that the Z is equal to the number of electron minus 2, which is 52. So if you look on the periodic table, the element with Z equal 52 is tellurium. Okay, so 52, we know that that equals 52, and 52 plus 76 will give us the Z. And here it's 128. And we know that the net charge is 2 minus. So this you can solve it very easily using the periodic table and with using the relationship between the mass number and the number of protons. Okay. So when you go to exercise number 3, here the atomic masses of lithium-6 and lithium-7 are given, and they ask us to calculate the natural abundances of these two isotopes, knowing that the average atomic mass of lithium is 6.941. So we can remind what is the average mass, M average. Okay, we know that it's equal to the mass of lithium-6 times the percentage of lithium-6 or the abundance plus the mass of lithium-7 times the percentage or abundance of lithium-7 and then divided by 100. So here we can put X equal the percentage of lithium-6 and Y equal the percentage of lithium-7. We know that X plus Y equal 100. And we know that 6.941 is equal to 6.0151, which is the mass of lithium-6 times X plus 7.0160 times Y and divided by 100. So we have equation with two unknown, X and Y. So we can compute, for example, here, one way to solve it is X equal 100 minus Y and fill this to this second equation. And when you calculate, you will get that X, the percentage of lithium-6, is equal to 7.5, and Y as a percentage of lithium-7 is equal to 92.5. So we can reflect a little bit on this result. So when you look at the average mass, it's equal here to 6.941. So we know that it's closer to 7. So we should have more of the 7 lithium. Okay, you should have more of this isotope, which is logical. So we have more of this one than on this one because the mass is closer to 7 here. Okay, closer to 7 than to 6 when you get the average mass here. Okay, that is all for exercise number 3. Let's move on to exercise number 4. So exercise number 4 is about naming naming the following compounds. So we have A, that is based on H plus, and a common anion that you have to know, C2H3O2 minus, which is the acetate ion. So when it's based on the 8 ion, we need to replace the 8 by ic. So it's going to be acetic, and we add acid. Okay, when we look at B, it's based on the ammonium ion and the nitrite ion. So the naming will be ammonium nitrite. So you keep the name of the cation ion, the name of the anion ion, and you remove the ion in between, and you get the name of the compound. If you look at C, it's based on cobalt, that can be 2 plus or 3 plus, and sulfur. So if you look at the stoichiometry, we know that it's based on cobalt 3 plus and sulfur or sulfide ion. So here we're going to have cobalt 3 sulfide. Okay, so for D, we have iodine fluoride. This is a molecular compound, iodine. We keep the name of the first element. And for the second one, we keep the beginning and we replace the N by ide, chloride, iodine chloride. For E, it's based on lead. It can be 2 plus or 4 plus. And the phosphate ion. So this is one that you should know. Okay, if you look at the stoichiometry, we can see that it's based on lead 2 plus and the phosphate ion. Just by looking at this number, okay, we know that the 3 is coming from the phosphate and the 2 from the lead. Okay, so we know that it's going to be lead 2 phosphate. Okay, this is E, and for F, based on potassium, and one ion that you should know, which is iodate. So it's going to be simply potassium iodate. Okay, let me see if I can erase to have more space. So always remember, if it's the ionic compound, remember that you need to know the name for the cation and the name of the anion, and you put them together and remove just the ion in between. Okay, so for acetic acid, it's also the 8th one. So you have the 8 ion. If you have the 8 ion, to get to the acid, you just need to remove the 8 and put ic and add acid at the end. So acetate will give acetic acid. Iodate, for example, will give iodic acid. Okay, so these are some ions that you should know. So we can go back to J. So for J, it's based on H plus and sulfate ion that you should know also. That's going to be, if it's the 8, sulfuric acid. For H, it's based on strontium 2 plus and nitride and 3 minus. Strontium has only one oxidation state that is possible. So it's going to be strontium. We don't need to specify the charge. Strontium nitride. Okay. Now I1 is based on aluminum and sulfide going to be aluminum sulfide. Okay, when we go to J, based on S on tin, it can be 2 plus or 4 plus. And on the oxide ion, so here we know that's going to be 4 because we need 2 oxygen to balance. So it's going to be tin 4 oxide. Okay, we have sodium ions and chromate. It's going to be simply sodium chromate. Okay, the last one is a little bit tricky. L, it's an acid because it has H plus and it's based on this ion. You should know this one. This is hypochlorite. Okay, so when we have to name an acid with an "ite," you need to replace the "ite" by "us," and you keep the prefix. So it's going to be hypochlorous acid. Okay, that's it for this exercise. Let's go to the last one, which is we have the name and we need to get the formula. So for A, it's based on chromium 6 plus, oxide O2 minus. So to have something neutral, it's chromium O3. For B, disulfur dichloride, so it's molecular, so we have S2Cl2. Be careful, this is different from SCl2. For S2Cl2, the structure is like this. And this is different from SCl. Okay, for C, nickel 2 fluoride, so this one is easy, 2 plus, and F minus, going to be NiF2. Okay, for D, aluminum nitride, aluminum is 3 plus, nitride is N3 minus, going to be Al. And for E, nitrogen, so N, it's going to be molecular, so we keep the name of the first element, H3. And this is also known as ammonia. You should know this one too. And F, the ammonium, we know it, ammonium ion, NH4 plus, and sulfide, SO3, 2 minus. So it's going to be NH4 2 times SO3. That's it for this recitation. See you again next time.